Hi everyone. In this video, let's understand the cluster capacity design criteria for Amazon EKS cluster. It's a very critical decision because it includes right sizing the containers, right sizing the nodes, choosing the right instance types, which means it impacts bin packing, resource utilization, which means the cost optimization is also impacted, and also choosing the right metrics to scale the containers and the nodes, which means the availability of the service is also impacted if it's not designed properly. So let's get started. Let us say we have deployed one EKS cluster in the cloud with control plane in the data plane. Control plane is created in AWS managed VPC and AWS managed account. The data plane is deployed in customer VPC in the customer managed account. Both the data plane and the control plane are connected via cross-account ENIs, Elastic Network Interfaces. Now, where do we start from here? Let us say we have one node group in the cluster with some EC2s running there. First, let's deploy some sample application using the deployment controller. What we need to decide first is the right metrics to scale this. So how do we determine the right metric to scale this application? So it depends upon the nature of the application. This application can be a batch processing application. That means it will process some messages from SQS queue or consume some events from some event broker. Or this application can expose the services to the clients via internet through some load balancers. In this example, let us assume that this application is exposed to internet via load balancer. The clients will be sending the traffic via load balancer. Let us send heavy traffic to this application and determine the CPU and the memory utilization for the given traffic. What I would recommend is test the load on the application with different traffic patterns. One regular traffic patterns you can use and one high load traffic patterns you can use. So once you send the traffic in these traffic patterns, you will understand how much CPU and the memory consumption is happening in the container level. So which brings us to right sizing the application. Based upon the CPU memory utilization, we can configure the request and the limits with the CPU and the memory at the container level. And this has to be applied for every microservice running in the cluster. Then, once we decide what is the right metric to scale these containers, then we have to figure out the right scaling configuration also. How much of extra buffer we need to keep in mind in case if there is spiky traffic. This extra buffer can handle the additional load by the time the new containers are created and getting ready to handle the new traffic. Let us deploy one more node group with visit instances there. Let's deploy the metric server. Metric server is an open source Kubernetes component which provides the standard metrics. So along with the metric server, let us deploy the vertical pod autoscaler and horizontal pod autoscaler and KEDA, which is Kubernetes event driven architecture. So depending upon the nature of the application, are we scaling the application based upon standard metrics like CPU memory, or are we scaling the metric based upon certain events? So based on that, we can decide either HPA or KEDA based solution. Vertical pod autoscaler is also useful in certain situations where we cannot scale the pods horizontally. We need to scale them vertically, which means increasing or decreasing the size of the CPU and the memory for that particular pod. Once you identify the right scaling metric and the right scaling configuration with the required over buffer capacity, then you can configure these controllers. These controllers will configure the deployment object, which in turn will influence your pods. Apart from right scaling configuration, we need to choose the right sizes for the nodes. One of the recommendation for this is to figure out the vCPU or the memory ratio for a given pod request. So for example, if you have a pod with a request 100 millicores of vCPU and 200 MB of RAM, which means the vCPU the memory ratio is 1:2. 1:2 means the compute intensive instant types are recommended, which is C4, C5 series. If the VCP and the memory ratio is around 1:4, then we can use general purpose instant types, which is M series or T series. If the CPU and the memory ratio is 1:8, we can use the memory intensive instant types, which are R series. Once we choose the right instant type, we need to decide the size. Should we go for example, M5 dot large, X large, 2X large, or even 4X large? This is based upon the part density. How many parts do we need to deploy on a given node? So this is depending upon the part sizes and the node sizes. Around 10 to 15 parts per node is a decent part density that we can start with. So another important thing we need to keep in mind is the daemon sets. Daemon sets runs on every node and they also require certain CPU and the memory. When choosing the size of the node, we also need to keep the capacity requirement for all the daemon sets in the clusters. Then we decide the CPU memory configuration for the nodes. It's important to keep in mind that all the nodes in a given node group should have similar vCPU in the memory configuration. Then how many node groups do we need to keep in the cluster? One node group is recommended to keep all the important parts, for example, metric server, vertical pod autoscaler, CADA, cluster autoscaler, Prometheus Grafana, any critical parts which needs to be running all the time can be kept in one dedicated node group. And we can have additional node groups for the workloads. You can have one or more workload based node groups. Then we need to decide on scaling solution for the nodes, which is the cluster autoscaler solution. There are many options available. For example, you can use a Kubernetes open source component called cluster autoscaler, which is common across all the clouds, cloud agnostic solution. You can use that. It works based on the node groups. The other option is Carpenter, which is a node group less design, which is also open source and quite performant. Both the cluster autoscaler and the Carpenter will scale the nodes based upon the number of pending parts in the cluster at any given point of time. So let us take a summary on the cluster capacity design. First, we have to do the load test to right size all the application parts in the cluster. And then choose the right EC2 instant types and the sizes based upon the vCPU and the memory ratio of the pod request configuration. Then decide the optimal number of node groups. One node group could be for all the critical parts, the remaining node groups just for scaling your workloads. Then we also need to decide the right scaling metrics based upon the nature of the application. If it's a batch processing application, probably we'll be leveraging some SQSQ or some events depth. Or if it's a load balanced based application, we can use standard metrics or the number of requests coming to the load balancer. Then we also need to decide on the cluster autoscaling solution to scale the number of nodes. It could be Carpenter or cluster autoscaler and with optimal configuration.